Hey guys, what's up? My name's Dan, and I'm here with my friends Chip and Stephanie. And I don't know if you've seen this cool challenge that GCHQ, a British intelligence agency, recently posted on their website. But if you go to canyoufindit.co.uk, there's just kind of a weird string of letters, and you have to figure out what to do. And it looks like those things lead to more questions. So you can go try it out, and then come back here. And the rest of this video, we're going to talk about how you actually solve some of these puzzles.
Okay, guys, we're gonna work on the first problem now. So, first, I took the string from the question and I copied it into Mathematica and I just joined it as one giant string here. And now let's just figure out if this is just simple substitution cipher. Okay, so let's do a tally of the different characters. And now let's sort this in a descending order. Okay, so it seems like Q shows up the most often, then ETA or ETO, so on and so forth. Let's do a search of English frequency list to compare this. Nope. English letter frequency. Okay, so let's just do a quick list plot of our guy. And then here is what the axis should be labeled. Okay, so let's compare these two pictures. So aside from the strange Q, it seems pretty similar. You have ET and then ETAO, ETOI, and if you just compare them, it seems like the frequency is similar to that of just a regular English language. And if it was a substitution cipher, there would be something jumbled up and mixed up. So, okay, maybe it's not a substitution cipher. So what's another pretty simple cipher? The transposition cipher. Okay, so first let's look at the length of this string. So that's 142. And if we factor that, it factors into 11 times 13. So let's do a transposition of the characters of the string. First partitioned into 11 by 13. Okay, so it says A O Q N U Q Q. This doesn't make a whole lot of sense. So what about 13? Okay, so AQ and then computer Q, wood Q. Okay, so this seems to be making some sense. So let's make this easier to read. And it seems like the Q's are just fillers, so let's get rid of that. So take the Q to spaces. And now we have a computer would deserve to be called intelligent if it could deceive a human into believing that it was human. www.metro.co.uk/Turing. So let's go there and see what happens. metro.co.uk/Turing. And now we have challenge 2. And as for the answer for the first question, seems that Turing is the correct answer.
All right, guys, so we're on challenge 2 now. So let's go ahead and download this file comp1.key. See what it is. And let's see. If we open it up in Sublime, we can see that it is an RSA private key. Now, if you're familiar with RSA keys, or if you do some Googling, look on Wikipedia, you know that it's actually a number written in base 64. So that's why there are all these characters in it. And this one is actually pretty simple if we try to convert it from base 64. So let's just Google base 64 converter. Paste our string in. Let's see what it decodes to. So we have a lot of garbage, but then we see this address www dot something what is something dot something. So this kind of looks like a URL, but we're not sure. So let's take this, open up Mathematica again. Let me just call it something. Okay, so it kind of looks like stuff has been shifted around, and if you look closely, basically every pair of letters has been switched. So we can go through it by hand, or we can use Mathematica to do it. So let's say partition the characters of the URL into groups of 2. And then let's reverse each pair. And then let's flatten that. Yep, and now we can see it's coming together. String join the whole thing, and we get www.thisisgloucestershire.co.uk/Bletchley. So let's go to that site, see what it looks like. If it'll load. And we're on to challenge 3. And if we go back to where we were, the answer to the second box is Bletchley. All right, so now let's try to take a look at challenge 3. So we have this long string here, and it looks like it's just a bunch of numbers in hex. So let's see what we can do with it. Let me just make it look more presentable. Yeah. Okay. Cool. So let's try to get some info about this. I'll call it hex in Mathematica. Oops. Ooh. Get rid of these weird characters. Doop. 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 Cool. Yeah. Let's just look at the string length. All right, so it's 256 characters. And if you know that each of these characters is 4 bits, so 2 of them are a byte, then you know that this is actually 1024 bits long. And if we go back to our key from the first part, it's actually also 1024 bits long because this RSA key happens to be one of the more common ones that is 1024 bits long. So maybe this is something that has been encrypted, and we can use this key that we were given in challenge 2 to decrypt it. So the RSA encryption scheme basically works by to decrypt, we have some ciphertext, so I'll rename this hex thing to C for ciphertext. Um, and then, all right, so we can get some info on the RSA key that we have by running OpenSSL RSA dash in and then the key file comp1.key and then dash text dash no out. And here's some of the different parts of the key. So we have our modulus and our private exponent, and these are the things that we want. So let's take our modulus here, and we are going to have to do some manipulating with it first to get it into a manageable state. So let's call it M for mod. And what we're going to have to do is, let's see, string replace white space character. Whoops. Character goes to nothing. And let's do colons also go to, whoops. So what does that look like now? Okay, cool. Okay, so now let's copy the plain text and convert it from base 16 to decimal. So this is actually the decimal version of the mod that OpenSSL gave us in hex. So let's rename M to that. Oops. And now let's just do the same thing with D, which is our private exponent. So let's take that string, do the same thing, paste it in, blah, blah, blah. What does D look like? It's that. Copy the plain text, convert that from hex to decimal. So now D is that. Cool. So now we have the decimal version of our mod, the decimal version of our private exponent, and we have our ciphertext, but that's still in hex, so we have to convert that to decimal as well. What do I want? That. So let's just do get that, and then convert that from hex to decimal, and then C is that. Cool. So now we have our three things. We have our ciphertext, our mod, and our private exponent. And the form for getting our message back, so message is going to equal C to the D mod M, but Mathematica, we can just use the power mod function. So we can do power mod C, which is our ciphertext, D, which is our exponent, and M, which is our mod. Then we get back this other decimal number. So now we can do base form of that. And let's put it in hex again. Cool, so it looks like there's some kind of pattern going on here. So maybe this is actually some ASCII characters. So let's try to convert that back to ASCII. Try to convert them. Let's look for some kind of online ASCII converter. Hex to ASCII. What is this one? Nah. This one. Nah. This one? Nope. Alright, yeah, so let's try to paste this string in there. There's some weird little text errors. And let's convert it. And we see www dot something something. So it's another scrambled one of those URLs. So let's just do the same thing we did before. And in fact, we can just kind of see it actually. If we just reverse things, you can see www dot THEREG. So it's the register.co.uk, and then Enigma 2013. So let's go to the register, and we're on to challenge 4. Cool.
All right, so what do we have here? It looks like we just have a picture with seemingly any direction we could go. So let's just go ahead and save this to our desktop. Call it Enigma 2013. Okay, and let's see what we can figure out. Okay, so we have this picture here. Looks pretty uniform, looks like a normal picture. But what we can do is we can open it with the text editor. Okay, and this is just garbage, really. But we can notice that it says JFIF right here, which is a synonym for JPEG. So if we search for this, we see it appears a second time. Not only that, but this weird V, Y umlaut, weird V, double cross also appears over here as well. So this probably means that there are 2 images in here and we are looking at the header. So what we can do is we can literally just delete the first one and save it. And boom, the image has now changed to another URL. So what we can do, so if we type in Enigma 2013 from the last challenge, now we can type in Colossus. Colossus. Okay, cool. And we are taking to, what is this? Evening Stand Colossus. Okay, and what's going on here? We have another link, canyouFindIt.co.uk/secured. Okay, if I hover over it, it'll take me somewhere. Oh, it takes me back to the original page. So, I mean, we can just guess. We can type secured here. And it worked. So with that, you can enter in your name and maybe get a Nexus 7 or a Raspberry Pi.